as a quick review, last time we worked on the question A, which is a non-uniform charge distribution is given for a sphere, and then we try to find the total charge on the sphere, which means that we need to do a triple integration over the volume so that we can find the overall charge on it. So for question B, yeah, what is the field? What is the field magnitude at B? R equals 0. R equals 0. R equals 0 is very trivial, which means that E should be equals to E should be equals to 0 for R equals to 0. And it is very trivial because you can just imagine you have a very tiny sphere, and then which has a radius of 0, so there should be no charge inside it, and so there will be no electric field. So at the center, at the very center of the sphere, E should be 0. So for the next one, we want to calculate the E field for R equals to capital R over 3. So actually now we need to calculate the E enclosed within the inner circle, so that we should repeat what we have done in question A, but just make small changes. Actually, I don't start from the very beginning. Actually, we only replacing this capital R into R over 3. So actually, it would be sigma rho S over capital R, integration from 0 to capital R over 3, and then R prime to the third power dr, and integration from 0 to 0 to pi psi theta d theta, and then this is pi, and then 0 to 2 pi d phi. So this case, this is r to the 4th power, small r to the 4th power, and then we substitute capital R over 3 inside. So it would become R over 3 to the 4th power, or over 4. And then this one would be the same 2 for this term, and then this one is 2 pi. So that finally, it would become wow. Rho S over, wow, 81, yeah, 81, because this 4 and these two can be cancelled, so it would be 81 pi r to the 4th power. So this Q will be equals to 4 pi well, 4 pi r square. R square is this small r, which is r over 3 square for I. Yeah, this is the surface area of the sphere, and then times the E. Times the E. So that this is the Gauss law. This is the Gauss law. And finally, the answer will be E equals to rho s over 36 epsilon naught r. For r is smaller than capital R. Then we substitute all the number inside. So we have rho s equals to 35.4 times 10 to minus 12, which is rho s. R is 5.6 centimeters, which is 0.056. All over 36, epsilon naught is 8.85 times 10 to minus 12. So the answer will be 6.22 times 10 to minus 3 Newton per Coulomb. So if you can understand, part A, then part C would be nothing but changing the capital R into R over 3, because we only consider the charge inside a sphere with a smaller radius. And then we repeat the Gauss law, and not repeat the Gauss law. We use the Gauss law. This one is 4 pi small r squared, and small r is capital R over 3 here. So the term so this term yeah, become that one. Yeah, maybe I forgot epsilon 0 there. Yeah, I forgot epsilon naught. Epsilon naught. I forgot this term here. So that here we have epsilon naught. Okay, any questions? So if no, we move to the next one. Next one is we want to calculate E at small r equals to capital R. So actually we already done this part in the first small question. We have the total Q to be pi rho s r cube. So we can just use the Gauss law, 4 pi r square. R square is capital R square equals to epsilon. This one is A, and times the E equals to rho s pi rho s r cube. So this is what we have for the. So this is what we have the total charge for part A, and this is the Q enclosed for a Gaussian surface which has a radius r to be at least capital R. So, or maybe we can just write this one with small r here. We can just write small r into here. So therefore, all r is larger or equal to capital R, it would be correct. And then we can find that E would be rho S over 4 epsilon naught times R cubed over R squared. So it's nothing but some algebraic calculation. So we divide this part on both sides, and then we can substitute small r equal to capital R, and it will become rho S R over 4 epsilon naught. So it will be 35.4 times 10 to minus 12, and then times R is 0.056, and then 4 times 8.85 times 10 to minus 12. So the answer will be 5.60 times 10 to minus 2 Newton per coulomb. Or you may write it as 56 milli-Newton per coulomb. Both are acceptable. So it asks you to graph E versus R. Actually, I just if I just make this term to be small r here, will give another expression, not this way. Actually, it should be like here is r squared over 4r, or maybe I can rewrite it like or I can rewrite it at this stage. I can write it as E E would be rho S times R squared over 4 epsilon naught R, for R is smaller than R. And in this one we have E to be like this. So it is rho S times capital R cubed over 4 epsilon naught small r squared, which is R is larger or equal to R. And then if we would like to draw it out, and then the x-axis is R, y-axis is E, so that we can see that this is inverse proportional to R squared. This is proportional to R squared, and inverse proportional to R squared for the other case. So it will become like this. This is proportional to R squared, and inverse proportional to R squared would be something like this. And then this is R.